Good evening, friends. Welcome to Eastern Academy. As a part of embedded system programming, today we are discussing about digital electronics, session 7. And in the previous sessions, we discussed about logic gates and logic functions and the application of combinational, sequential, and tri-state logic. And today we are going to use all of them to create a very, very nice and important component. It's called RAM. Okay, it's called so-called random access memory. We will discuss about that. So, the digital electronics, the basic thing is nothing but a switch. The switch, if I control manually, then that is electrical. If I have a switch which I control using electrical, then that is electronics. And we call this as a gate. That's it. And in the electrical, we connect the switches in series, we call series circuit. And here we called AND gate, AND function. Same way, if I connect the switches in parallel, in electrical, we call parallel. In electronics, we call it a OR gate. And here we connect a short circuit. For example, I connect a switch in parallel. When the switch is off, the bulb is on. When switch is on, bulb is off because zero voltage. Here we call that as a NOT gate. This is all we discussed. That is 3 logic gates. So in electronics, in especially digital electronics, which we are discussing, the basic thing is gate, which is nothing but a switch with electrical input. And the application is 3. And or not. Only 3. The application of this, we discussed about combinational logic, multiple inputs, and sequential logic, which has a name 101101. And here D, Q, C. And tri-state logic. Enable, input, output. That's it. You see, I'm just trying to tell you what you have to remember. Remember what is gate. Remember the 3 gates. Remember the 3 logics. Nothing. Don't try to remember everything. And application of that, we are going to discuss now. How do I going to use that? Okay. So now we are clear where we are now. Now let us take a like a last class what we discussed. I take a simple D flip-flop, but 8 wires, 8 bit. That means that if I draw the /8, that means that internally I have 8 D flip-flops, single bit. That is single bit. So I have 8 single bit D flip-flops. Combined together, if we put /8 mean internally, we can call this a 1 8-bit D flip-flop. Please understand the difference. How I write here? I write here 1 8-bit D flip-flop. Here I write 8 1-bit D flip-flop. That's the difference. So when I combine 8, I get 1. So what I have done here is I have added a tri-state which gets out. So this is D, this is Q. And here is a signal called C. And here is a signal called enable. So there are, see, there's a data here. I can give 8 inputs. and I get a Q output here. That's right. Now think here. If I give here a table, we draw a table. C enable. When C is 0 and enable is 0, what happens? Let's say C is 1. D is, I give D as some data, 12. I give 12. 12 means 0, 0, 0, 1, 0, 0, 1, 0. That's 12. Remember always. I try to write only binary into 12, hexadecimal. Now what is output? Now the operation is Q becomes 12. Not Q, sorry. Not Q here, sorry. In between, you call here M, whatever it is. M become 12. Q become Qn minus 1. The old one, because the enable is 0. Now, if I don't give anything D. I make C as 0 and enable as a 1. Then M is 12 only, but Q also become 12 because enable is 1. This switch is on. Now the third operation is, I don't give anything. C is 0, M enable is 0. Then M is 12, but this one is old. Qn minus 1. This one is, sorry, not Q minus 1, is no voltage. To understand now, that means that the first, when C is 1, the C is 1, we write. When C is 1, we write. When enable is 1, we read. And when C is 0 and enable is 0, we store. The 3 operations. Actually, we do 3 operations. One operation we write. The second operation we store. Sorry, we read. And third operation we store. That's why this is called 1 byte. 8-bit means 1 byte. This is called 1 byte. Read, write, memory. Understand? 1 byte read, write, memory. If you take this abbreviations, important one, RWM, this is actually called 1 byte, RWM. But we are calling this as a RAM. I'll explain to you after some time why we are calling RWM as a RAM. I'll tell you, you should know that. There's a big difference between, there are 2 RAMs are there. We'll discuss about that next. What is 2 RAMs? Is it clear? So we have done a small application of your D flip-flop under tri-state. I hope this is clear. This is D flip-flop and this is tri-state. We have used them. This is the sequential logic, tri-state logic. But later only they found out that the whole logic, they surprisingly find out. When I am writing, I'm not reading. When I'm reading, I'm not writing. Understand? When they write, they don't read. When they read, they don't write. I don't do. See, let's say, when I talk, I don't listen. When I listen, I don't talk. The same way they thought that we are not using this memory for both simultaneously. So what they have done was very nice thing. What they did was, they made this one connected here to D. Understand here? They have connected with the, so this wire act as an input output. This is input, this is output. But this wire can be output or input. When it's output, it comes here. But the problem is, you are not supposed to drive There's a tri-state here. And there should be other tri-state when I'm writing. I should not, let us say, for example, the class, there are so many people are there. When the teacher talks, others have to listen. All the people have to listen. When others are, somebody is talking, the teacher have to listen. Teacher should not talk. Like that here, there's a block. The block which writes. Actually, this block is called microprocessor. This micro block is the one which is writing. So he will not, he is the one who is giving both the signal, C and enable. When C is given, enable will not be given. When enable is given, C will not be given. Or both. When I'm storing it, I will not do the both. Now they did a small change. You know, here, the C, what I'm doing, I'm writing. So they call this as a write. I'm using enable to read. So they're using the name as read. So they started calling the signal as a write and read. And this is data. Just changing the name, that's all. No, you don't do that. Because that's not the way they designed it. They found out surprisingly, they don't do that both. Initial days they did it, but later they found it, they were not. There's another problem they face. If I have a chip, if this is 8 pin, this is 8 pin. They're going to waste 8 pins. Understood? The pin outs on the chips are very, very important. They want to save the pin. Now what they did was, they made this as a single block. They made this as a single block. See here. They made as a single block, this one. Of what? 8 inputs, data, input and output both. And this is a signal called write. And signal called read. And here I have a D flip-flop. Where this goes as an input. Here there is a tri-state which goes here, output. And for example, as I told you that these are given by your microprocessor. That guy is also having a switch. When he gives, the switch is controlled by write. When write is 0, okay, that time the switch is off automatically. So I also don't speak. Like I means microprocessor. And the read is connected to enable and the write is connected to C. So this is called 1 byte RAM. You understand now? This is called 1 byte RAM. It's supposed to be called read-write memory, but we are calling it as a RAM. You are writing, you are storing, you are reading. Do you understand? You are writing. That's what here. The D flip-flop is used to write. And the D flip-flop output is used to store. When I give an enable, the data comes out, it's called read. Then people thought, hey, if I have only 1 byte, I can store only 1 byte. I want to store 2 byte. So what they did was, they copy the same block. They copy the same block. That you should understand now. That is, I copy the same block. See here. This is 1 byte RAM, 1 byte. This is 1 byte RAM. That's it. Now I have a data and I have a write signal and I have a read signal. And here also I have a data. And I have a write signal and read signal. When I give data 65, when I make write as a 1, it will write. When I make read as a 0, that will come out. When we make both the 0, the 65 will be there inside. When I make both 0, the 65 will be inside. Now, same way, when I give here 55, when I make right as a 1, the data will be written here 55. When I make right as 0, read as 0, nothing, it will be there. When I make read as a 1, the 55 will come back. You understand now? So I use 1 block. What people did was, I have connected this 8 data bus to both same. And this they called as a write 0, read 0. This they called as a write 1, read 1. Now understand, there are 2 things. There are 6 operations. See that? How let me write them one by one. Write on, this is called location 0. This is called location 1. Write on location 0. That's the first operation. Second operation, read from location 0. And third one is store in location 0. And fourth operation, write on location 1. Fifth operation, read from location 1. 6, store in location 1. See that? Now, when these 2 are 0, 0, I store. When write is 1 and all are 0, when all are 0, I am doing the first one. Am I right? Because write 0. Then when I make that is 0, when I make write 1, read 0 as 1, I make the read operation. When I make read as 0, write 1 as a 1, I make write location 1. When I make read as a 1, I make this operation. When both are 0, store. Am I right? So when I give everything is 0, the data is stored here. Am I right? But when I am reading or writing, I cannot do all simultaneously, I'll do only one. So what people did was a small thing, they did a small change. Here is a trick, understand. What they did was, they used only one wire. I have 2 locations. I have used only one wire called A. Only one wire. Understand now, I used one wire, not multiple wires. When I use one wire, this wire can be 0 or 1. If this wire is 0, it represents location 0. The wire is 1, location 1. I use the one wire. Then what they did was, they have used this one, we connected internally. See that I do connect here. Yes, I want the space here. Then they have a wire signal called write and read. Please understand how things are developing slowly. What they did was, I have a write. Now I have a gates. See here, understand. I have a gates. Everything is AND gate, nothing else. I told you repeatedly, I will not be using more than that. What the people did was, they used the inverter here and connected to both. And without inverter, they connected to both. Now understand? Now, when this guy is 0, when this guy is 0, this becomes 1. So these 2 will be selected. These 2 will be 0. So not selected. When this guy is 1, these things will be 0. So this will be off. Because in AND gate, if one input is 0 I don't worry about the other input. And this one, let me draw this in a slightly better way. I think it's confused you. Let me make 4 AND gates. 4 AND gates. And connect them to read 1, write 1, read 0, write 0. 4. Now I get a signal called write, which is connected here and which is connected here. Let me use different color. I get write signal, which is connected here and which is connected here. I use read signal, which is connected here and which is connected here. Okay, now I have one more signal called A. The A, I invert it and connect it here, which I can use a different color. And same A without inversion, I connect it here. You see here. So when there is a here, if A is 0, since there's an inverter here, this becomes 1. So this is 1 and this is 1. Whereas this becomes 0. These 2 gates output is 0 always now, because one input is 0 AND gate. But since they are 1, if a write is 1, write 0 become 1. If a read is 1, read 0 become 1. When both are 0, these are zeros. Now I can draw a table. I draw a table now. See that. I draw a small table now. I draw a table. The input is how much? 3 signals. A, write, read. The output is 4 signals. What are the 4 signals? Write 0, read 0. Write 1, read 1. Now when A is 1, both are 0, all are 0. Now A is 1, write is 1 and read is 0. So A is 0, sir. We assume A is 0. Then when write is 1, write 0 become 1, all the others are 0. When A is 0, read is 1. Then read 0 is 1, others are 0. When A is 1, both are 0 means all are 0. See, when read and write are 0, everything is 0 because all are AND gate. Now, when A is 1, write is 1. Then write 1 is 1. When A is 1, read is 1. See that? If you look at the thing, I do either a read operation or write operation. And I'm reading only one location at a time. I cannot, since A can be 0 or 1, the A can be 0 or 1. I cannot do simultaneously 2 operations. I cannot select 2 locations. Do you agree this? Since A is a 1 wire, one wire can be either 0 volt or 5 volt. It cannot be both. That means that I can select only one of the locations, and which I already told you that we don't get write and 0, 1, 1. That's illegal. We never do read and write simultaneously. We do either read or write. That is the way we have been designed the circuits. There is a one restriction in digital electronics. We don't do read and write simultaneously. We do either write or read. Agree this. Now, see here, I'll draw this in a different fashion, different way, please. That will be make you clear. Now I have told you what is the thing. Now I have 2 locations. 2 locations. Am I right? I have 2 locations. And this is location 0. This is location 1. And this guy is having a D. This guy is having a D. And This guy is having a write. This guy is having a write. Same block. I copied the same block. No difference at all. Then this guy is having a read. This guy is having a read. So what we have did was we connected the data wires. So data goes to both the people. But who will accept it based on these two signals? This signal is called write 0, read 0. This is called write 1, read 1. There's only one data. Data, only one data. Not two data. Now understand one thing. I have a signal called A. I have a block. I have two blocks. The blocks are having a name. The output is called select 0, select 1. This guy name is 0, this guy name is 1. As I mentioned, your combination logic. This guy name is 0, that guy name is 1. Now I have 1, 2, 3, 4. Each two signal, I have an AND gate. Understand now? Now what we do here is, this one is connected to read, write. This one is connected to read. But the select goes to both the people. Same way, the select 1 goes to both the people. This one is connected to read, write, and this one is connected to read. So when the write comes, based on what you do, that particular signal will be connected. So that operation will be determined by these three signals: A, write, and read. If I expand it, you will understand. Now maybe I'll do the next one. Then you will be able to slightly understand. Maybe if you don't understand, ask me, please. Now what I'm doing is I'm drawing 4-byte location 0. See here. Location 1, location 2, location 3. There are 4 locations. And there is a common data line D, 8 bits. That is going to everybody. That goes to everybody. So the data goes to everybody common. This is an input output. This is a bidirectional. I can read or write. So go back to the signal byte. Now, everyone is having a separate signal called read write. Everyone is having a, see, this guy is having a write 0, read 0. This guy is write 1, read 1. Write 2, read 2. Write 3, read 3. So everybody is having a 2 signals. Now I have 2 inputs. I have 2 inputs called A0 and A1. See, I have 2 signals now, A0 and A1. So A0 and A1, 0 means 0, location 0, or select 0. See that. 1 means select 1. 10 means select 2. 11 means select 3. So I have 3. Now you see, I have a 4 combinational blocks. 4 combinational blocks. Please understand. This name is 00. His name is 01. His name is 10. His name is 11. Now these 2 signals, let me draw like this, /2, going to everyone. Till this point, very clear. Am I right? So I get here, select 1. I get here, select 2. I get here, select 3. I get here, select 0, 1, 2, 3. This you know that, how to solve this. We have discussed the combination logic block. If I have a block, the name is 10, the output is 1. So I have two inputs. I have a two input AND gate. Then I have two inputs. One correct. This is MSB. 0 means I have an inverter. That's it. This we discussed in the combination logic block. Remember that. That's why I told you repeatedly. You understand this. Now let me remove these wires because it's a little bit confusion. Instead of right here D. Then you will be understanding that it's D. All are connected. Now here I have how many AND gates? 1, 2, 3, 4, 5, 6, 7, 8. Understand now. These two are connected by select 0. These two are controlled by select 1. These two are controlled by select 2. These two are controlled by select 3. Now, this is connected here. This is connected here. Now, this input is right. This input is read. This input is right. Right. Read. Right. Read. Okay. So understand one thing now. What is inside? The inside is having a 8-bit D flip-flop and a 8-bit tri-state logic. That is what 1 byte. And that has a C and enable. So this is your block. And if you take a 1-bit D, this is having 8 D flip-flops. 8. If you take 1 D flip-flop, that has so many gates inside. So that means that we are making a building blocks. How we are making a building block? From switch, we form gate. From gate, we formed combination logic, sequential logic, and tri-state logic. Now we are forming a read-write memory. So go back and make sure that, see, this is what you study the entire 1 semester of digital electronics, which I made it through on 8 sessions. And make sure that you thoroughly understand. If whoever interested, please let me know. I have a self-assessment test on the app. I will enable to you all the questions. I have about 100 questions are there. If you practice them, you will know that where you stand. Of course, you see the solution also there. So you will be able to understand that. And I also have 100 questions on number systems on app. Whoever ready to take, let me know. I can assign them. So you understand now. That means that I arrange them like this. I do them separately, then you will understand. First of all, go back like this. Go back to the old board. Back to square one. If I have a 4-byte memory, I need to have a 4 1-byte. 4 1-byte. This is called location 0, location 1, location 2, location 3. And each one is having 8 D flip-flops. 8 D flip-flop. Please understand. If you expand this, that has about 8 single bit. D0 to D7. Please understand that. So now, each one is having a signal called write 0, read 0. Write 1, read 1. Write 2, read 2. Write 3, read 3. Let us assume that you can tell me that where do you now say I'll do one thing. Then, since I have a 4 location, I have a 4 combinational blocks. See here, I have a 4 combinational blocks. Since I have a 4 locations, I have two inputs, A0 and A1, because 2 power 2 is 4. I can give either 0, 0 or 0, 1 or 1, 0 or 1, 1. That's all, the 4 combination. So either 0, 0 or 0, 1 or 1, 0 or 1, 1. Now, what we are doing here is, let me draw this in a cryptic way, bus-wise, A, 2. Now, this is connected to all the people. Now, this guy name is 0, 0, 0, 1, 1, 0, 1, 1. Understand now? This guy is having a signal out called select 0, select 1, select 2, and select 3. Now we have 1, 2 gates. I have here 1, 2 gates. I have 1 and 2 gates. This select goes to both the AND gates. And the select 1 goes to both the gates. Select 2 goes to both. And this output is called write 0, because write. So write and select 0 is called write 0. And this is read. Okay. Select 0 and read is called read 0. That is location 0 read. Then write is called write 1. Read. Read 1. Write. Write 2. Please understand, I given a name called write. That means these are all connected. If I connected, it will be so clumsy. That's why I didn't go. So these are all connected. Please, that if I give a same name, write and write and write, all of them are connected. The read and read, 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 all of them are connected. That means that I get 2 signals, write and read. I get data. The data also comes here. Goes out. Sorry. Let me put it here. Data. Let me draw internally. Okay. All the people are data. D. As long as the names are same, they are connected. Please understand. There's a convention. If I have 2 blocks, if this case is called A, B, and B, that means that B and B are connected, A and A are connected. If the names are same, they are connected. We don't show sometimes connections. Otherwise, there'll be the circuit full of wires. Do you understand? Now what I do here is, I make this as a block. Please hear. I make this as a block. This is called 4-byte read, write memory, or we call RAM. This is called 4-byte RAM. What is the input? Data, 8-bit. And address, 2-bit. And this called A is called address because I'm addressing the location. Then write is called to write, read. Do you understand this? Now I'm going to erase the inside. Then you will know that. That's why I'm asking you. If you have it, please look at once again and let me know if you have any doubt here. Tell me where you have a doubt. You have a doubt to location 0 or 1 or 2 or 3. Or select 0 or select 1, select 2, select 3. Or write 0, read 0, write 1, read 1, write 2, read 2, write 3, read 3. Or data, address, read, write. Where you have a fault. But these are all inside. What is outside is only these 4 signals. Read, write, address, and data. Have a look at them and let me know. Is it clear? I hope things are clear. Am I right? No doubts. Otherwise, you can go and watch your home. Now, I erase the whole thing internally. We don't need that. because that is a black box chip. The outside chip is only this, the block. After erasing, somebody is asking it out. Clear? Oh, thank you. That's fine. Now, I make the whole thing as like this. This is the way we write. This is a building block, a small one. See here, I have A. I have A, write, read, and D. A is 2, write is read of 1, 1, data is 8. This is called 4-byte read write memory called. We are calling read 8 memory as RAM. Here's a 2. Understand now? Since this is 2, I call 2 power 2 is 4. That's why I call 4-byte. Now think of it. I want to have a 8-byte. What people did was they put 8 1-byte block, 8 blocks. Understand? They have 8 blocks. And all of them are having a D. All of them are having a data, which are connected. D. When I say all D, all are connected. I don't have to show connection through wires. Now I have a signal here called write 0, read 0, write 1, read 1, write 2, read 2, write 3, read 3. Like that, this become write 7, read 7. I have 8. Now I have 8 combinational blocks. Please understand. I have 8 combinational blocks because I have 8 blocks. Since I have 8 blocks, I have the A is having 3 wires. A is having how many wires? 3 wires. Why? 2 power 3 is 8. Now this 3 wire goes to everybody. And there is a 1 second write and read and data. All are same. This data goes to data. That's correct. Now, Now this guy's name is 000. This guy's name is 001, 010, 011, 100, 101, 110, 111. This guy is called select 0, select 1, select 2, select 3, select 4, select 5, select 7. Sorry. Now, for read and write, there are 2 AND gates. For this read and write, there are 2 AND gates. This read and write, 2 AND gates. As same we discuss. Since there are how many things? 8 into 16 AND gates are there. And here we connect select 0. These 2 you connect select 1. These 2 you connect select 2 like that. Now this will be given to write and read. The block is same. Please understand. The block is same. There are 2 AND gates. And there's a select signal. This case is having a write and read. When a select is 0, both the outputs are 0. Nothing is selected. Now when select is 1, if a write is 1, this become 1. If a write is 0 and read is 1, this become 1. This is 0. Now both are 0, then both are 0. That's it. This, I can make this as a block of like this. See here. A, 3 wires. Write, read, and data, 8 wires. Understand now? This is having 2. This is called 8-byte RAM. Now think of it, same thing. If I have like this 16, I'll have 4 wires. And names that means that I have a 16 combination logics. Every combination logic will select 1 device. That means that everybody is having a name. That name is selected by the combinational logic. So now think of a minute, 1 minute. If I have, think 1 minute. If I have 10 address lines, write, read, and data. Data is still 8. There's only 8 bit because every line I'm storing only 8 bit. Okay. Now think of it. What is the size? 2 power 10, 1 kilobyte. This RAM size is 1 kilobyte. Understand? If you put 20 here, then the size is how much? 1 megabyte. That means what? I have 20 means what? 0, 0, 0, 0, 5, 4 20s up to FFF. Okay, 1 million. That means that I have 1 million bytes on 1 million combinational logic. And each logic, there are 2 gates, then 2 million AND gates. Think of it. That means that if you put 30, 1 gigabyte. If you put 32, 4 gigabyte. If we do 24, 16 megabyte. So that you should know, which that's why I'll ask you to watch the number system video. That means that if your computer or mobile phone, if you say that I have 4G RAM, think of it, how many address lines, how many bytes are there internally? Such a huge, am I right? You cannot imagine how big it is. Nowadays, think of it. You are getting a drive called 1 terabyte. There is 2 power 40. Think of it those days. Maybe in future you may get petabyte, 2 power 50. So this is what all about RAM. A RAM means internally a D flip-flop. You can write by using a write signal. You can read by using a read signal. You can select it using the address. And you can read the data on this data lines. So the information comes through the data line. The write will control whether you're going to write or read. And the data will come here or you're going to give. So, and if both of them are zeros, whatever you store will be there. That's why we call memory. And that we already told you that I have like this. Please understand, when you don't give write or read, the data is stored here in between. People always ask where it is stored. It is output of Q because Q is, this is the D flip-flop. When the C is 0, when the C is 0, the Q is Qn minus 1. But that will not come out because read is 0. So that if people ask where it is stored in between the D flip-flop and the tri-state. That's the place the data is there. Like this is 1 byte. Like this, so many bytes are there in your memory, depends on the size of the memory. But there's only one problem here. There's only one problem here. That problem is, these are all start with what? These are all, if you see that thing, these are all start with the RS latch. This is start with RS latch. You remember? If you go back to the your sequential logic, this is R, S, Q. Normally we always start with 1, 0. If this is 1 and this is 0, this is 0, this becomes 0. 1. The 1 comes here. 1, 1, 1. This becomes 0. The 0 comes here. 0, 0, 0, 1. So the output is R, yes, Q is 0. Then I make S as 1. Then it becomes 1, 0, 0, 1, 1, 1, 1, 0. So it becomes 0. When you make 0, 1, when you make R as 0, 0, 1, 0. This become 1, 1, 1, 1, 1, and this becomes 0, 0. So this become 1. Now when both become 1, 1, let's say make this as a 1. 1, 0, 0, 1, 1, 1, 1, 0, 0 like this. See, I'm not going to explain to you once again. This is we have very well explained in our sequential logic class. Please watch that. The trick here is somebody would ask somebody actually asked why we don't start from 1, 1. What is 1, 1? It's a qn minus 1. Initially, when you start, everything is x. We don't know. Everything is x. If I start with 1, 1, the output is what? X, you don't know. So you have to start from a known state. That's why either you should write 0, then make him to remember. Write 1, make him to remember. When you do the power on, when you do power on, the output is X. Nobody knows till you write. So you have to make a write first before read. Because this guy is, that's why they call this as a volatile memory. Your RAM is a volatile memory. The moment you save something, that's gone the moment you remove the power. Okay, that is, people don't like that. We don't use 0, 0. 0, 0 is a very trivial condition. When I have a time, I'll explain to you. We don't use 0, 0. There's a big problem is there. That why it is, we'll explain later. Right now, I don't want to waste on this time. Okay, industry don't use 0, 0. 0, 0 means illegal. I'll explain to you sometime, maybe even today. After the class, I'll explain to you. Not in the class. That will confuse, that will put you a lot of confusion. Okay. No, 0, 0 is not memory. 1, 1 is memory. Please understand. 1, 1 is memory. 0, 0 is not memory. 1, 1 is memory. 0, 0 is not memory, please. I've explained to you that. So 1, 1 is called memory state, not 0, 0. Okay. This is the volatile. Now people are trying to find a memory where things should not be volatile. Understand? Things should not be volatile. So they are trying. So there are two types of memories. One is called volatile memory. This is RAM. That is actually read, write memory. Other one is non-volatile memory. This we will discuss after the break. So please understand, your RAM is nothing but D flip-flop, which has so many internal memories. And you have address, write, read, and data. That's it. So please understand, wherever I draw a RAM has address to select the location. If the address is 10 means the size is 2 power 10 bytes, 1K. This 8 represents what is the size of a line. Right now we are discussing about 1 byte. Everything is 8-bit. There are memories available. This is 16-bit or 32-bit also. But right now this is only 8-bit. And write and read. Till you understand everything, let us discuss only about 8-bit. 8-bit is easy to understand. Once you understand, we can move to 16 or 32. So now with that, let me close the topic. So RAM is nothing but a chip which has address, write, read, and data. You can write or you can read. This is called we use only 8. This could be anything, n number. 2 power n is a size. The address is used to select the right location using the combination. So this has combination logic, sequential logic, and tri-state logic, all the three. Nothing more than that. So if you watch our lecture, even tomorrow after the class, we discuss about non-volatile RAM, the next session after the break. If you watch the whole thing, the whole 8 sessions, this during the weekend, you will thoroughly understand. Before you proceed further in digital electronics or embedded system programming, these 8 are very important. These 8 are very important. I've concise everything brought into 8 into 2 hours, totally 16 hours. That's all. 16 hours lectures if you watch. If you don't understand, let me know anything. If you don't understand, let me know anything. Okay, we will discuss the small break, then we will discuss about the non-volatile memory.